project that is being done. The UN Big Data Regional Hub in Brazil be introduced to the teams as well, so that you are more familiar with how data can be used and what kind of solutions that you can create. Thank you. Now, next slide, please. Yeah, before we go deep into the details of this webinar, we would like to express our excitement, and we are very overwhelmed with the response and registrations that we received. As of now, after the selections, we have over 1,000 participants in 450 teams, representing over 60 countries participating in the UN Big Data Hackathon. We are very overwhelmed and very excited, very happy that such a global crowd can come together for this experience. And we all expect and hope that you have a very wonderful experience during the hackathon. The hackathon will be happening from the 8th to 11th of November, as mentioned before. So going into the data sets, before we go in detail, I would like to mention that all of the public data sets that can be found online will be allowed to be used in the UN Big Data Hackathon. So any data set that you think would be relevant to create a project in accordance with the theme is allowed, and the only restriction is that you are not allowed to use private or copyrighted data sets. And if we find that any of the copyrighted data sets has been used, that will be terms for disqualification. Other than that, please feel free to use any data set that is available online, which is public and open. And yeah, as a good experience, the teams are also encouraged to share the data sets with other participating teams as well.
However, please note that we'll be providing you with a set of data sets. So of course, we won't be revealing them because it will definitely give out the team, and the team will be revealed 1 week before the hackathon. But we just wanted to let you know that we definitely created a really nice set of data sets from different sources. And we wanted to kind of introduce this to you so that you can, if you have time, kind of go over it and take the time to get experience with it and take a look at it. So the main difference between the two tracks is that the Big Data Experts track is going to heavily rely on the use of AIS data, which is going to be offered through the UNGB platform. And that is, of course, the reason why we're basically separating between the two tracks. But other than that, both tracks will get access to a very wide range and widespread of sources. And of course, don't worry, like you won't have to go on each of these different websites, which we'll link here, by the way. You can click on it. We'll share the slides after the webinar. We'll make sure to have a dedicated environment for you to get access to all of these data sets. Now, going into the data sources. So we'll be providing you with data sets coming from the Open Data on AWS, which was also offered last year. We'll also create data sets from the World Risk Poll that was put together by Gallup in collaboration with the Lloyd's Register Foundation. We are very excited today to have a speaker that will guide you through this particular data source today. We'll also provide you with data sets from the UNICEF data portal, and we're also excited to have a speaker today, a big data expert who will walk you through it as well. We'll provide you with data sets from the Humanitarian Data Exchange, also referred to as Xtx. And again, we are very excited to have a speaker to share this with you today. And finally, we'll also give you data sets coming from the World Bank Open Data, which was also provided last year and is a great source for really cool data sets as well. There are other data sets and data sources that we didn't mention here, such as data coming from the IMF, the UN, or the World Health Organization. And again, like we do not ask you to be familiar with any of these data sets. We put these links for you to take a look at it, to be curious, to see what it looks like. And of course, closer to the deadline, we'll be sharing the theme as well as data sets, and you'll get access to all of them. You do not have to, focus on all of them at once. You can focus on one only. So yeah, like this is just an introduction for you to get a feel for what the data sets are going to come from.
Yeah, thank you, Mima. And as far as the youth track is concerned, We are very happy to announce that we will have the use track will have access to the AWS platform. So we are very excited for this collaboration with AWS. More details on the AWS platform itself will be shared with you on the webinar on 31st of October, as some of the details are still being finalized. But as of now, we can let you know that all of the, as mentioned before, all of the data sets on the registry of open data on AWS will be made available. We have filtered out some of the relevant data sets in regards to the theme, so that it will be easier to use for the participants. And these data sets will be made, hopefully will be made directly available on the platform itself, as along with all of the other data sources, some of the other data sources directly on the platform itself. So hopefully the participating teams will have much more ease in accessing all of these data sets and data sources. I would like to invite Jaye to go through the big data platform and introduce the AIS data sets.
Okay, thank you, Abhijit. So for the Big Data Expo track, we would provide the teams with a data source of AIS data, which can be accessed through the UN Global Platform. So next page. Well, the AIS refers to the automatic identification system used by ships globally. It is an automated autonomous tracking system which is extensively used in the maritime world for the exchange of navigational information between AIS-equipped terminals. So this system was originally developed for ship collision avoidance. Well, next page. The AIS system was developed by the International Maritime Organization in 2004. It is a fully automatic transceiver system with global coverage. The real-time data is tracked and collected by different data providers and is made available to the AIS community online. So here, next page has an example of the data received by the AIS system. It includes, among other things, like the vessel ID, vessel name, vessel type, vessel size, and the nationality of the ship. It also includes information such as the destination, geospatial location, speed, and navigational status on the ship. So next page. As well as the sources of the transmission, the date, and the time of the transmission. Please go next page. So this provides an incredible rich data set for use. The most accessible and efficient place to obtain AIS data is via the UNGP platform. It is a cloud-based platform with access to global shipping data. The platform also has the functionality for the manipulation of data and can provide a sandpad area for experimentation. We would provide the big data expert teams with access to the platform during Hackathon. So for more information about AIS data, you can take our e-learning course on the UN Big Data Learning Platform. Thank you.
Thank you, Jaye, for introducing the AI stack. Today, we have a panel of speakers who will introduce you to some of the data portals that the participating teams will have access to during the hackathon. We have Mr. Thierry Schlaudecker, I hope I'm pronouncing you right, from UNICEF, who will introduce you to the UNICEF data portal. We have Dr. Aaron Gradner from the Lloyd's Register Foundation to talk about the World Risk Pool 2021 data. We also have Mr. Faisal Thamran from the United Nations Office for Coordination of Humanitarian Affairs to introduce the SDX data portal as well. First, we'll move on to Terry Schlaudecker. So Terry Schlaudecker is a data management consultant with the UNICEF's data and analytics team. His role focuses on ingesting data into UNICEF's SDMX-powered indicator data warehouse. as well as creating and maintaining data visualizations generated with the warehouse's data. Recently, Theory has been developing various materials on how to connect to the warehouse using analytical softwares such as Tableau, Power BI, Excel, or Python. He is here with us today to demonstrate how to simply generate such an endpoint URL to the warehouse's RESTful API. Over to you, Mr. Theory.
Thank you very much. Thank you for the introduction, and thank you for having me here. So feel free to move to the next slide. So UNICEF maintains a data warehouse that is based on the SDMX standard. So it offers the API functionalities that are covered by that standard. So this demo will show you how to access two of our APIs. One lets you connect to the indicated data warehouse. So that's the actual indicated data that our data teams generate. And the other one is the API to the reference data manager. So starting with the indicated data warehouse, it's really super easy to query the warehouse using REST APIs. So these queries can then be used to pull data from the warehouse to any analytical tool that allows for CDS. And for that purpose, there is a web service builder that is available at sdmx.data.unicef.org. And then you simply go to web service and data. So when looking at the web service interface, you'll be faced with a variety of filters. The two filters that we'll have a particular look at are agency and data flow. So all the official data that we have is under the UNICEF agency settings. So unless you were advised to use a different agency, you will absolutely want to select UNICEF here. Now, under the UNICEF agency, the chances are very high that you want to select the global data flow. And so the global data flow has cross-sectoral data that is disaggregated only among a few common dimensions. As you can see on the screenshot, those are a geographic area, indicator, and sex. You could also be interested in then more topic specific data flow, because we have data flows on nutrition, on education, on health, and those are also available under the UNICEF agencies. And those data flows have many more dimensions available. So when you select a topic specific data flow, the available dimensions appear down below. And they allow you to refine your search. So if you select education, for example, then you'll see that education level and wealth quintiles become available dimensions. The next important thing to select is the data format, and that in this case you want to choose CSV as the format. Because if you're building a query for Microsoft Excel, for Power BI, for Google Sheet, or for Tableau, those are the settings you want to select. Now, if you want to further refine your search, you can use the filter that are shown down below. So that's it. You're basically shown a URL in the query URL box, and you can use that query in any of your analytical tools like Excel, Power BI, Python, R. So just simply copy the link down below, and maybe just one little trick. You can add a parameter at the end of the link to specify to limit the output to the last observation, to the single last observation, or the last n observation, with n being the desired number of observation. Okay, next slide. Another API that could be interesting is the reference data manager, and the reference data manager is is kind of like our Bible when it comes to UNICEF reference data and the reference metadata on things like indicators and regional aggregations. And it basically holds all the information about how indicators are calculated, including things like definitions, computation methods, survey population, etc., etc. So if you can find some value in this, feel free to visit the API documentation that is available at the link in this on this slide. One thing to keep in mind, and feel free to move to the next slide, is that if you dig into indicator metadata, you may notice that some are extensively documented and other are a little less well documented. So SDGs, for example, are very well documented. So that could be a good starting point. And a couple more thoughts on some of the challenges that you may encounter. So the data sets that we store are not regular time series data because their sources are from household surveys, and the teams who compute those indicators are not always comfortable estimating the values in gap years. So you will find gaps in the data, but that doesn't need to mean that you can't explore creative ways to fill those gaps and overcome these challenges. And the same applies to potential lack of disaggregations for the data. So for example, let's say there is no gender breakdown for a specific indicator. You could go grab UNPD data that we also store in the warehouse, and you could figure out what the average percentage by sex is, and then use that estimation to extrapolate and make up for the lack of disaggregations. And yeah, that's just one example of a creative workaround. So yeah, that was it from my end. And if you have any questions or concern, feel free to contact me directly as well. Thank you.
Thank you so much, Thierry, for the great introduction. Again, as a reminder, like this is one of the data portals from which we'll be selecting a set of data sets for the hackathon, and this applies for both tracks. So hopefully you get a feel for what the UNICEF data portal looks like now. Thank you so much for the introduction. Great.
Thank you.
So next up, thank you. So next up, we have with us Faisal Thamreen. He's currently working as a humanitarian data advisor for the Pulse Lab in Jakarta and data manager for Humanitarian Data Exchange, the HDX. So he actually focuses on how to use humanitarian data to better address in a timely manner humanitarian crisis. And we're very excited for him to show us today what the HDX data portal looks like. And again, this is one other data source that will be made available during the hackathon for you to experience and analyze the data from. So thank you so much, Faisal, for being with us today.
Thank you. So thank you so much for the intro. Let me start by thank you for include the Xtx as a part of the data as the data sources. So I'll go brief to present it basically what the Xtx is all about. Can you go next? So the Center of Humanitarian Data is basically based in The Hague and managed by OCHA. So we are part of the United Nations Office for Coordination for Humanitarian Affairs. Can you go next? So the mission of the center is to increase the use and the impact of the data on humanitarian response. So we are focusing on collecting most related data related to humanitarian crisis. Can you go next, please? So what is humanitarian data? So we are looking into three categories: data about the context of the crisis, the data about the people affected and their needs, and the data about the humanitarian response. Can you go next? So the aims is to make sure that the use of the speed of data. So we want to make sure that the flow of information is quite fast. It's not really sitting in the people computer, but basically share openly with everyone and publicly available. We're trying to connecting the network. So we are build our community at the moment. We have so many organizations from different countries sharing data with us, then we try to make sure that there is increase of use of the humanitarian data through the whole kind of system. Go next. So we are basically a global team. We have different people sitting in the different offices. I'm based in Jakarta. We have people in Bangkok, Dakar, Nairobi, Bucharest, Geneva. Our headquarters in The Hague, and then we have some people also in New York. Can you go next? So yeah, I'm a bit kind of fast to make sure that you'll be able to see more about the Xtx instead of this the intro one. So we have a 4 focus area, which is data services, data responsibility, data literacy, and predictive analysis. I'm part of the data services where we basically manage the Xtx to maintain that exchange. Next, please. Here's the website. So the Xtx is basically is a data portal. So what we do is basically we connect with organizations that would like to share data with us. So the organization will have responsibility to maintain the data, to update the data, and at the same time to hold the content of the data. What we make sure is basically all the data that's sharing within the Xtx, one is in readable machine format. So we will be able to see most of this data come in as CSV, Excel files, geodatabase, GeoJSON, or even some of this come as an API. We launched in 2014, and currently we have around 20,000 datasets coming from around 253 locations with almost like sources from different kind of organizations. We have around 200 kind of organizations that actively share the data in Xtx. Can you go next, please? So here's some of the glance about our data set. So we have like 1.5 million users at the moment, unique users that currently come into the Xtx to share their data or even download some of our data. We have 1.8 million downloaded in 2021, 300 now active organization, and we have around 19, now it's around 20,000 data, 20,000 data set, which is around 250 location. Can you go next? Here's is our stats. So during the COVID, our users become quite hugely increased. There's a lot of users coming in into Xtx to getting mostly the COVID dataset. We have got a lot number of COVID dataset also available within the Xtx. Now, can you go next, please? Sorry. Now, I explain one of the features that we have in Xtx called data grid. Can you go next, please? So data grid is basically a feature that we have, which is to try to help user in their quest for a good and relevant data. So we have some sort of like a research a couple of years ago to try to understand what is our users need. And then we basically create what we call the data grid. So what we've done is basically we create 6 categories that we think is very important for humanitarian kind of a response. And then within that 6 category, we divide it into around, currently it's around 20 subcategories. Can you go next, please? Here's an example of the data, this overview of the data grid. So for the time being, we only focus to around 25 countries. From those 25 countries, the focus is mostly countries that in very active kind of humanitarian crisis situations. So we have like Afghanistan, Burundi, South Sudan, Sudan. Within those countries, we divided into certain categories. So we have 6 category focus from getting the administrative boundaries data, the IDPs data set, most of the infrastructures data set, and then population kind of data set. This data set is the one that we selected. It's mostly the one that is being used by humanitarian agencies within those countries. Can you go next, please? This is one of the example that we've done with our data set. So we create what we call COVID-19 Data Explorer, which is mostly coming from around quite a lot of numbers of data set. I'm quite really not remember how many, but it's quite a lot of data set that we compile and then create one dashboard. So in here, you'll be able to see the information about the COVID itself by countries. You should be able to see people in need, the acute food insecurity, severe acute malnutrition, school closure within those kind of COVID situations, food market price, immunization campaign status. There's a lot of data set from different data sources that we compile and then put it as one. This is coming from mostly the data sets that it's sharing by different organizations, and we compile as one, and then we create some sort of like a dashboard for a user to be able to easily navigate if they want to know more information related to the COVID-19. Can you go next, please? This is one of the also example that we have where you'll be able to see that there's a lot of what we call data that we collect or coming from different organizations that use in the different platforms. So for example, the New York Times, the Economist, and BBC use, there's lots of our data sets that to show, for example, this is Ebola cases. There are some information related to the OPT West Bank, and then the information also in the BBC related to Ebola spread in African region. Can you go next, please? I'm supposed to do live demo, but I'm not quite sure I'll be able to share my screen. Is that possible? Okay.
Yes, definitely. You should be able to. I'll stop sharing.
So
we can see your screen.
Yeah, this is our web page, which is basically the home screen. In here, you should be able to share anything that you want. So, for example, if I click South Sudan as a country one, and then I search the data. So what you see here, you should be able to see how many data set is available, but how many organizations sharing the data related to the South Sudan. And then in here, you will be able to see, for example, this is an example to say the blue one, this is the what we call the data grid. So you'll be able to see the blue one is basically the data is quite complete, meaning it's updated regularly by the organization, and they're presenting the information that is being used within the country mostly. So this is there's a 6 category in here. You see affected people, coordination and context, food security and nutrition, geographic and infrastructures, health education, and population social economy. Then we have around 20 subcategories, which is some of them is basically coming from different sources. Below one, what I would like to show is basically each of these features that we have, it's basically divided into some categories. So for example, you should be able to see in here what is the data set is all about. Is it is it geodata kind of a type? Is it coming on the subnational level? COD is mean a common operational dataset, which is mostly related to, for example, administrative boundaries, populations datasets. And in here we have several kind of information that we will also create like a quick chart, so people will be able to see the key numbers of the data without even download the data. In here we have based on the location, so you can also use an API. Later on, I'll share with you the link to our Xtx API Python one. So in here you should be able to select by country, and then what is the format of the data that has been shared in here. As you can see, it's a CSV. Most of these data it's a machine readable format. Mostly if PDF one, it's the one that is showcased. So example of what is the data produced, what is the produce products that is being produced based on the data sets. And then it's below, it's related to which organization that share the data. So each of organization will have different data set in here. And then we have also the tag. So it's related to the way how we tagging some of the information. Is it about agriculture? It's about aid funding, aid workers, or it's about airport, or anything that you would like to see. This is what we have. We have around 125 tags at the moment, I think. And then when you go down here, as explained before, I think in the beginning, most of our data set is it's a Creative Commons license. To be able to see what is most of this data license is available in here. When you click on the data sets, you should also be able to see two tabs. One of the tabs is basically related to the data and the resources. So for example, what we are looking here is about South Sudan requirement and funding, which is a part of some of this is because of COVID-19 data explorer that I'll show you before, and then the South Sudan data grid. Here's what we call the quick chart, which is we are enabling to produce based on the information that we have in here. This is the resources. So every time the data it's updated, it will be included as a new kind of source, what we call this is resources. So in this data set, you have a different resources of the data. And we have the metadata. So source is basically the data, where's the data coming from, what is the source of the data. Contributor is the organization that's sharing the data with us. This is, we have a date of the data sets, when it's updated, the expected update frequencies, the location of the data set. So you'll be able to see based on the countries. This is the feasibilities. We have two types of sharing data. One is basically public. One is we call private or Xtx data connect, which is mostly data that it would one day organization only share the metadata. So it makes sure that people are aware that the data is available, but it's not openly publicly available. The other one is related to the license, and then this is the methodology on how its data is being collected, and then some information related to the caveat, and this is the tag and file format. The other thing that I would like to show you is basically we have this Xtx Python API. In here, you will be able to see how you will be able to push or even pulling the data from the Xtx. I will suggest you to read the whole kind of documentation on how the API works. And if you have any questions, I think on my last slide, you will be able to find my name and email one, which is you will be able to send me, and then I'll be try as much as possible to answer all the questions that we have. I think that's it from my end. Thank you.
Thank you so much, Faisal, for the excellent introduction. So hopefully everyone on this call now is familiar with how to access HDX, and we encourage you again to go take a look at the data sets. We'll make, again, a set of them available for you on a special environment, but you're more than welcome to go explore it after we reveal the theme to add more. All right. So
I'll put it my detail in the chat after this. Thank you.
Thank you so much. Appreciate it. All right. I'll be sharing and giving up to Abhijit next.
Thank you, Nima. Next up, we are very excited to have Dr. Aaron Gardner from the Lloyd's Register Foundation to talk to us about the World Risk Pool. Dr. Aaron has over 15 years of experience working as a scientist with a strong background in quantitative and qualitative research. Over time, he has pivoted away from bench-based science towards working with even larger data sets, requiring bespoke analysis and visualization approaches in order to successfully communicate findings. At Lloyd's Register Foundation, Dr. Aaron works as a data and insight scientist with a mission to improve access to foundation datasets and identify novel and exciting stories and drive impact related to all of the foundation's key aims. We are very excited to have Dr. Aaron, and over to you, Dr. Aaron.
Thank you very much for that intro. Would it be possible for me to share the slides just so I don't have to ask you to change? Would that be okay?
For sure.
Absolutely.
Share my screen. Okay, so I'll give you a bit of an introduction because Lloyd's Register Foundation may be less familiar to some of you than the other organisations that have been talked about. So the LRF is an independent global charity with an important mission, which is to engineer a safer world. And we do this by supporting high quality research, accelerating technology and driving impact through education and public outreach. And as part of my role, we're stepping into the idea of sharing these huge data sources that we have internally with wider organizations and groups. So for this call specifically, I'm going to talk about the World Risk Poll, which is one of our outreach and impact schemes. So this is a poll which occurs every 2 years. We're in our second occurrence now. And in this 2021 version, we polled 121 countries and 125,000 individuals in these countries. And we asked them a broad spectrum of questions assessing their perception and experience of risk in daily life, and also in the greater sense of how they worry about risk in the far future. So by having this global coverage, we can get data about places where there is little or no official data on safety and people's perception of risk. And as part of this poll, we've also done 3 deep dives into specific areas: disaster resilience, especially relating to climate change, violence and harassment at work and people's experience of that, and finally, how people think about data privacy and artificial intelligence and their use of social media and other internet services. The really exciting thing about this data set is that this is the second running of the poll. We previously ran it in 2019, and this allows us to build on existing data. And obviously, as everyone's aware, 2019 to 2021, there was a huge event in the world, which was COVID-19. So it gave us a unique perspective on seeing how COVID-19 impacted on people's sense of safety. So I'll just run through some very high level findings from the data, and hopefully these can enthuse you about using our data set in your projects. So this question was asked people, what's your greatest risk to safety in your own world? And in the pink values, we can see the figures from 2021, and the blue and the arrows show the change compared to 2019. So what you can see is that road-related accidents and crime and violence still remain people's highest areas of concern, even though they dropped compared to 2019. But they were still much higher than COVID-19. So this was somewhat of a surprise to us. We thought COVID-19 would be by far and away people's main concern, but it seems that there's only a few countries and regions globally where this was true. Most people are still worried about much more day-to-day events and their health, their safety in relation to those. Climate change is another one that we're very interested in tracking across time and seeing how people's perceptions change. So comparing 2019 and 2021, the data was almost identical. There was very little change, no increase in people seeing a very serious threat, and only a very slight decrease in people who saw it as a somewhat serious threat. So this is even in the face of COVID-19. One, the positive outlook would be that people still remain that they see climate change as a threat, even in the face of COVID-19. A negative take would be that people's perceptions aren't evolving over time, even though we are experiencing more and more climate change related events globally. And then the most interesting set of data that possibly came out and relevant to this is showing that we can measure resilience through a variety of different metrics. So this one here is looking at global financial vulnerability. So we asked people, if you lost your job, how long would you be able to survive on your household savings and any other materials that you have in your house? And you can see that there's a huge global variation. So in Northern and Western Europe, there's a very small percentage who would say they would last less than a week. Whereas if we look at Northern Africa or Southern Asia, these percentages are much higher at about a quarter. And then conversely, looking at the other way, for people who could survive for 4 months or longer, you can see the opposite effect happening. Northern and Western Europe, nearly half of people felt that they had that resilience, whereas in Southern Asia, only 8% of people felt that they would be able to last or survive for more than 4 months if they lost their job. So we used all of this data to build this interactive resilience index. And this is one of the things that would be really cool and excited to see other people building with our data set. So using all of the questions, we composed this index with 4 major domains: individual, household, community, and society. And then we scored countries based on these. And as you can see that the GIF's been playing in the background, we have a load of other demographics that we can use to group and sort things out. So we can look at specific countries, we can look at gender, we can look at age, we can look at income groups, all of these different factors that we can combine in our data set to analyze things and identify areas where we would be able to have the biggest impact by making an intervention. So yeah, to carry on from that, resilience varies significantly at a global level, but the important thing to remember here is that we're asking about people's perception of their resilience. So you may find some countries which you would consider a bit of an outlier. So we were surprised to see that Vietnam came out as the most resilient country, but this was driven by a very strong level of societal and household resilience compared to other countries. At the other end of the scale, it maybe made more sense. Afghanistan was of the countries polled was the country which had the lowest level of resilience, and this was driven by low scores across all 4 of the categories, with an especially low score for individual resilience. And interestingly, this polling in Afghanistan took place just during the US withdrawal from Afghanistan, so it's a particularly timely set of data. But the real power in this data set is that we can combine it with other sources of data, not just our own, but other data sets out there. So, for example, we looked at the countries which experienced disasters, natural disasters, and climate change related events and correlated these with their resilience index. So there's a very general trend across the thing, but there's some very interesting outliers. So the Philippines, which is a country which has one of the highest incidence of natural disasters, also has the highest resilience. And this is driven by people feeling that their government, their neighbours and their community can support them in the event of a disaster, allowing them to be resilient in the face of that. And this is a really important point to get across, that resilience is a way of basically preventing disasters occurring. The natural event or natural hazard may occur, but in a resilient country, people are able to bounce back, rebuild and work together to come back. When that resilience is lacking, that's when the global disasters, the really high level disasters occur. And an example here was the floods that occurred recently in Pakistan. So I've just got two more interesting bits of data that I think would be interesting to people. So this idea about how people view support in their community and government is one of the ideas that keeps coming back in the data set, and we keep seeing these really interesting differences. One particular finding is that in lower income countries, according to World Bank income classifications, there's a much higher proportion of people believe that their neighbours and their community care about them a lot compared to higher income countries. So this sense of community resilience is always much higher in lower income countries. But then this conversely, this does not tie in with how people experience discrimination, which can be another factor that limits resilience. People who have experienced discrimination are typically less resilient than those who haven't. And here we asked the percentage of people who have experienced discrimination based on any of these characteristics shown here. And you can see that globally, there's quite a large number of countries where a high proportion of people have experienced this, but globally, more than 1 in 5 of people have experienced this discrimination. And there were certain countries such as the United States and Brazil that when we looked in and dived into the data, that you could see that there was multiple occurrences of discrimination. So people would experience discrimination based on their skin color, nationality and sex, all as a group as a whole. And this drove lower resilience overall. So that was just a quick snapshot of the data that we have. There's lots of data on our website and the reports can be downloaded, and the interactive visualization would be great if you go and have a play with that. And I'd be happy to answer any questions by email or in the chat. And I will stop sharing there.
Thank you so much, Dr. Aaron. That was very insightful. Please do, really do encourage the participants to go through the World Risk Pool data. It is an excellent source of data sources. Over to you, Umayma.
Thank you so much, Abhijit. So I hope that you all got inspired by this excellent panel of speakers. So you have a feel for what the types of data we'll be providing you with look like. Again, we encourage you to take a look at them before we reveal the theme, because it might be insightful to know what they look like. And now the question is basically, it might be a little bit overwhelming. There's so much data. You don't know even what the theme is going to look like yet. And you might, ask yourself this question, like, what am I supposed to do? So again, last year we had like hundreds of participants. Each of them came with very different solutions. We provided them with public data sets, just like we will this year. And they basically came up with dashboards, with reports, with advanced machine learning algorithms to predict certain metrics. And these are all solutions that you can come up with. Once, of course, you know what the theme is, and the theme will be revealed 1 week before the hackathon. But in order to give you a feel for what you actually can come up with, we invited today last year's winning team from France, Team Sustainability, to go over their solution, what they offered based on the theme, which last year was COVID-19 and its impact on people. So they will share what they actually did over the course of 3 days. It is very short. It can be very stressful, but hopefully they had a little bit of fun. So thank you so much, Umayma and Jean-Philippe, for being here with us today. We're very excited to have you. And I guess the first question before we delve into your solution is, how was your experience with the hackathon last year? Did you have fun? Was it stressful? Yeah.
Hi, Umema. Thank you for having us. It was definitely stressful. 3 days is short. And like Jean-Philippe, Marine, and myself were not in the same country while the hackathon was happening. So it was a very big challenge, but extremely rewarding and a great experience. I think it taught us a lot. And it was also a great opportunity to connect with people coming from all over the world working on data and sustainability challenges. So it was a great experience.
Thank you so much. And so now that you've been able to kind of look into some of the data sets that are offered this year, and we have to say, we have definitely a much wider spread of data sources available and of such greater quality as well. What can you tell the participants, like, based on these data sources, like, how can they get started, even if they don't know the theme yet? Like,
I think there are two things. Like, the first thing is like go with the data sets that speak to you the most in terms of context and how it was collected. For example, where we had like lots of possibilities of data sets when we started, and we went for the Uganda household survey because we knew about Uganda. We have been working with this country. So I would say, yeah, go with the data set that sound the most familiar to you and that can, according to your gut feeling, provide some good answers to important learning questions.
thank you so much for your answers, Umaima. So now I won't leave up the suspense much more, so I'll let you and Jean-Philippe. Marine is not with us today, but hopefully you two can go over your presentation and explain a little bit of the thought process. How do we go from the initial data set to a raw product, even if it's not perfect? How do we come up with a project at the end of the hackathon?
All right, thank you, Umaima. So yeah, as we said, we were three working on this project. Jean-Philippe, who is a data scientist who works in Abidjan, Marine, who is a PhD in development economics, and myself, I am monitoring and evaluation manager working in France. So next slide, please. So we decided to focus on Uganda. Basically, we used some data sets available in the World Bank data macro library. So next slide. We wanted to understand better what was the household's vulnerability to COVID consequences in Uganda. So first, it's important to define what vulnerability is. So the vulnerability is the inability to resist a hazard or to respond when a disaster has occurred. So we wanted to see how households had been coping with the COVID-19 pandemic and all of its consequences. And we decided to focus on 3 sustainable development goals. So the first one being no poverty, second, no hunger, and third one, quality education. So for no poverty, we asked ourselves what were the household profiles that were the most likely to lose one or several of their income sources due to COVID. For no hunger, we focused on food security. And for quality education, we tried to identify households in which children were more likely to drop school due to the pandemic. So basically, I'll go quickly in the data, but we used 2 data sets. So next, yeah. The first we selected, there was a sample of 2,225 households in Uganda that were covered by several data collections. The first one being the LSMS survey. So it was a data collection that occurred before COVID-19 on the household socioeconomic characteristics. So next slide. And the second one was during the COVID pandemic, and it was the goal was to understand how these households coped with the COVID-19 consequences. So next slide. So yeah, by combining these 2 data sets, we were able to have predictors from the LSMS survey and predictions from the high frequency phone survey. So next. So yeah, the first step was to clean the data. There were lots of structural, we needed to restructure the data, check duplicate, rename columns to make them more transparent. Next slide. Then all of these steps are just data restructuration, so we can skip all of it. Yeah, so our first step in our analysis was to we did a clustering of the data sets. So we relied on an MCA analysis using the K-mean methodology. So we tried to segment the households based on their characteristics to identify a household group that was the most vulnerable to COVID-19. So we got, next slide, 3 clusters as shown as the visualization. So 3 classes of clusters. First class were poor rural households, second, vulnerable rural households, and third, urban, less vulnerable households. So then we tried to see if there were some patterns in the way they coped to COVID-19. Next slide. And we use Power BI to do so. And the next. So yeah, but once we had done this clustering, we wanted to go a step further and build a prediction model. So next step. Yeah. So Jean-Philippe is going to present you all of the different steps that led to building our prediction algorithm. Jean-Philippe, the floor is yours.
Okay, thank you, Maïva. Hello, everyone. So for our first model, we decided to define 4 categories for our first goal. So we have the household who has lost all their income, the household who has lost less than 50% of their income, the household who has lost more than 50% of the income, and for the last category, we have the household who has lost none of the income. So we decided to apply 3 approaches. The first one was the naive bias. And the second is the KNN. For the naive bias, classifier is based on the Bayes theorem. We assume that the presence of a particular features in the class is unrelated to the presence of any other features. So with the calcul of probability for each class, we classify household according to the highest probability. For the KNN, or key nearest neighborhood, is a supervised approach. To classify one observation, we calculate distances between one observation and the training data. So we selected the key nearest neighbors. Then, according the classes, we attribute a class to our observation. So here we decided to select the best one with the KNN, classifier because of its accuracy. So the accuracy confidence interval is an interval statistic used to quantify the skill of a classification method. So for our second model, we can skip this slide. Yes, this also. Here we just identifying food security vulnerability. So here we use we define here we have define just the index. We can skip the slide also. Yes, okay. Here we define also 4 categories of vulnerability concerning the security vulnerability. So we got the not vulnerable household, a moderately vulnerable household, a very vulnerable, and a severely vulnerable. So here we use a three approach. We add the KNN, the naive Bayes, and the decision tree. So as the name said, the decision tree consists to create a decision tree based on descriptors and value present in training data. Then algorithm does the prediction according the decision tree. So we select the best one according the accuracy CI, like we can see that. For our last model, our goal is to identifying the education access vulnerability. So we got here 2 categories: the children of the household who have continued learning activities, and the children of the household who have stopped learning activities after the pandemic. So here we are two classification methodology, a naive Bayes and the KNN. And here we decided to select the KNN. We can notice that the accuracy of the KNN is less good than the naive Bayes, but we select the KNN because the specificity was very better than the naive Bayes. So I let Sumaima to finish our presentation.
All right. So thanks, Jean-Philippe. So after we chose all of these models, we concatenated everything into one integrated solution that combined these three models. So then our last step was to apply our model to an existing data set. So lucky for us, we are working in a company that is named Touton that collects this kind of socioeconomic data in Uganda. So we used, next slide. So we use, next slide, remember, please. So we use the socioeconomic data, applied our model to it, and build geospatial dashboards, as you can see here, in order to see where were located the most vulnerable households on the three SDGs that we had identified. So on food security, education access, and household income vulnerability. So this dashboard is aimed at being used operationally, knowing where are the households that are the most vulnerable in order to help intervention targeting. Next slide. So yeah, our conclusion is, well, we had two approaches to try to better understand household vulnerability to COVID-19 in Uganda. The first step was to build a clustering model. And then we went a step further, building a prediction model based on socioeconomic data that is collected in a lot of organizations. So that was what we presented to last year's hackathon. So yeah, that's it for us. Thanks again to the organizing team for everything. It was a great experience, and good luck to all of the next participants.
Thank you so much, Umayma and Jean-Philippe, for the presentation. And to answer a question on the chat, last year was the youth track only. So, this is one of the most advanced solutions that we have. We had plenty of other solutions, and I think we shared some of these during the second webinar. So we do encourage you to take a look at it. So these are kind of, some of the solutions that participants came up with. All right, so we only have a couple of minutes left, so we'll go over our last but not least speaker. So just like we really wanted to be able to share with you what the last year's winning team did, we also wanted to show you another case of how to utilize these open data sources to come up with insightful information and projects. So today with us, we have Vladimir Gonçalves Miranda, who is a graduate in statistics and has joined IBGE in 2010 as a statistician at the Department of Price Indices Coordination. He has worked on different works with different problems related to the improvement and support to the price statistics produced at IBG, which is the Brazilian NSO. And today he'll be sharing with us some of his works. So thank you so much, Vladimir, for being with us today. And I'll give the floor for you for the next couple of minutes.
So thank you for this very kind introduction. So I'll talk a bit about some case examples of the use of web data for improvement of price statistics here in Brazil. So if you can move to the next slide. So one of the things that web scraping can allow is to automate manual collection performed on websites for sectors such as airfares. So for this sector, the collection was being performed manually on the websites. And what we have done here was to develop a scraper that inserted the inputs into the websites of the airfare companies and was able to extract the price information for this sector, since this is a very structured website. So next, please. And this process mimics what was being done by the field collectors, and we have compare the results of the manual and the automated process. And as you can see, they look very similar. And do this, we have been able to implement this kind of approach in production. And this was able to produce an effective way of collecting the prices and save an effort of collecting over 100,000 prices a month manually. So next, please. Another point where web scraping can be very useful is to allow the structure of information of different fields of the CPI basket, for instance, that would be difficult to extract by other means. And we were faced with this with the results of our last household budget survey, where we have seen that ride-sharing service have shown to be representative in the basket. And this is a very challenging sector to try to capture inflation, since it has a very dynamic pricing behavior. So due to the presence of this kind of websites, similar to those of airfares, we are also able to mimic the action of a user trying to demand a given ride and obtaining the respective price. And we were able to develop scrapers for this kind of websites and derive indicators for this sector. And next, please. As you can see, this approach was able to derive indicators for different regions and in Brazil, and is also running in production. Next, please. Another point where the web is a rich source of information that can improve the derivation of price statistics is the fact that e-commerce sites are also rich in other metadata characteristics, such as products attributes. And this is very appealing for the treatment of quality adjustments in price indices by use of hedonic models, where the price of a product is broken down as the contribution of the product's attributes, as you can see in this expression here. So one of the main difficulties of using this kind of approach in CPI is that manual collection on the field of additional products attributes increases the burden on the respondents and are very costful. So with the use of web data and web scraping, derivation of hedonics approaches become much more accessible to be implemented. So next, please. A sector that is usually affected by quality changes is the one of electronics and electrical households, since the products have a short lifetime and need to be replaced by new ones. So just to illustrate the problem here, if we try to compare the prices of these different products over time and calculate this price relative, as they have different characteristics, we might not be only capturing price changing, but also quality issues. So next. If we can then broke down the prices of the products into their characteristics, we are able to derive the price of the old product in terms of the characteristics of the new one and obtain a price relative that is free of quality issues. Okay, so next. Going beyond consumer price indices, other price statistics can also be improved by use of web as a source and web scraping techniques. And one of the other important statistics that we are addressing is the one related to the International Comparison Program, which makes use of prices of a list of catalog products to derive the purchasing power parity indicators. And as you can see here, we will get information of a catalog of products with all these attributes. And there's a list of different products that countries aim to track. And next. And we again can use web scraping, inserting these products descriptions into the, for instance, search engines of sites and extracting the results, and then filtering them by use of keywords or in machine learning techniques to extract the most similar products that we are looking for. So this is another approach that we are deriving. The next, please. And we are also working on a more generic scraper in collaboration with researchers from the Federal University of Minas Gerais in Brazil, where the idea here is to try to derive a more robust structure that tries to track the stores and products that are currently in our physical sample and try to find those in the internet. So this is a very challenging problem, and it is very important to try to scale the use of scrapers for other sectors that do not have a price aggregator site. Or next, please. So besides this, other sectors that are usually covered by this kind of techniques for hotels accommodation. This is more challenging than airfares, for instance, because nowadays the traditional collection is performed on the field, not on the website. So there's a different of sources here. There's also a non-monopolized sector, and hence there are many hotels with very different websites. So a suitable approach is try to look for site aggregators where you can extract prices of different hotels at once. So this is another source of information that we're exploring currently. Next. And finally, in a similar fashion, another important sector that you can also derive information is for second-hand cars, where again, the presence of these site aggregators with information on prices and characteristics of the cars can allow you to extract or derive price indicators and with hedonic adjustments. So that's all for me. So thank you very much for this opportunity.
Thank you so much, Vladimir, for the great presentation. Hopefully it was insightful again to all the participants to see all the great things we can do with data that is available online, and yeah, very advanced models as well. And this can definitely appeal to the big data experts track in particular to give them examples of what they can come up with. So with that being said, I think we are at the end of our presentation today. We hope that you were inspired and you have a clearer view of which big data sources will be made available and also what types of projects you could come up with. There have been some questions about last year's student experiences. We'll send them again. We did during the second webinar so that you can get inspired and have examples that can be very simple, very advanced. Like, we're not looking for anything specific. We're just looking for you to experience the hackathon and try your best. And so we hope that today's excellent panel of speakers helped you get a feel for what could be done out there in terms of dashboarding, advanced reports, advanced models, prediction models, etc. So thank you everyone for joining us today. We'll come up with more information about the hackathon very, very soon, now that we closed the second survey yesterday. So be on the lookout for you to be assigned to a team if you haven't already, and be on the lookout for the last webinar that will take place on October 31st, where we will be revealing the theme and giving you all the extra details for you to have an excellent experience at the hackathon. Again, big ups to the speakers. Honestly, like, you are all fabulous and really insightful. So thank you so much for helping us. And if you have any questions, we'll be sharing their information and contacts, so you can reach out to them and ask them questions if you have any. All right. So with that being said, we're ending the recording and the webinar now. Thank you everyone so much, and looking forward to seeing all of you very, very soon. Right. Goodbye.